coasts. But after roughly 7,000 or so years of the shoreline being stable, it's now moving. It's moving toward us. And it's moving toward us because sea level is rising. And sea level is rising because the climate is changing. That's not a question anymore. We understand that quite well. And as the planet gets warmer, two things happen. The ocean gets warmer, and as water gets warm, it expands, and ice melts. And all ice melts at 32 degrees Fahrenheit. It doesn't matter if you're a Democrat or Republican. So I'm only going to show a couple of images, and at first glance, this might look complicated. It's actually pretty straightforward, and what it is going back about 400,000 years, and this is mainly from ice cores in Antarctica, and we can actually measure the amount of carbon dioxide, a major greenhouse gas that's contained in these little air bubbles that have been frozen into the ice. What we can see are these very cyclical patterns in the order of about 100,000 years. And these are really also glacial, interglacial periods, but you can see after actually about 800,000 years of carbon dioxide being between 175 and 275 or 300 parts per million. It's not a lot. It's now about 40% higher than that, going to that point over the last century or so since the Industrial Revolution. If we look at global temperature, it mirrors that very, very precisely. So carbon dioxide is affecting global temperature. And if we look at sea level, again, the warmer it gets, the more ice melts, the more ocean warms, the higher sea level will get. And you can see, even if we go back here to about 120,000 years ago, sea level was actually about 25 feet higher than today, when the temperature and CO2 were a little bit lower than they are today. There's sort of a lag here. So what's coming is not going to be good because we can't turn this around quickly. So this is important just to see this relationship. What does that sea level rise mean for us? Next, Manu. Just to expand that sea level rise, for the last 150 years or so, we actually measured sea level from tide gauges on land, but those give a local value. Beginning in 1993, we launched some satellites that now record that very precisely from space, sort of amazing science. And you can see since 1993 to about 2020, how high it's gone up. It's now rising at about 3.4 millimeters per year, which is about a little over 13 inches per century. But next, if we actually look at the shape of that curve, the rate is increasing. The first 10 or so years, it was maybe 10 inches per 100-year rate. For most of it, it's been about 13 inches. That's the average. And right now, over the last 8 or 10 years, it's now rising at about 18 inches per 100 years. So the rate of sea level rise is accelerating. Next. So that means, oh, there should be one before this. Maybe we went to, can you go back one, Manu?
There's not one before it. I've got a couple other images. You're looking for another?
No, that's okay. We could do share screen, but I don't want to do that. The slide before that is a nice summer day in Capitol, and there's people sitting out here with their lattes reading the Wall Street Journal and enjoying themselves. And all of a sudden, we get to winter, a high tide, or an El Nino year. Sea level is coming over the wall. All those people, well, here's a guy running away. I don't know whether he has his Wall Street Journal, his latte or not. And water has come in as far as 2 blocks into downtown. So Capitol is one of our lower lying areas, but there are many others. Next, this is Beach Drive in Rio Del Mar in 1983, and I did a Sentinel column about this a couple of weeks ago. So these houses are frequently flooded. They all have boards that go up on their windows and doors. So this is gradually rising sea level is going to impact neighborhoods like this that are built almost on the sand. Next, The other areas that are going to be problematic with higher sea levels are where we built on bluffs or cliffs. So the higher sea level gets, the more frequently waves will attack the cliff. And therefore, the more rapid cliff erosion will take place. Now, there are plenty of places where we built seawalls and so forth, which will provide some temporary help. The upper left is Crest Apartments on Depot Hill in Capitola. This was back in the 80s, actually before the earthquake. That also took its toll, so that failure occurred and foundation support was lost. Now, 6 of those apartment buildings were taken down. Grand Avenue used to go the full length of Depot Hill. It now stops here and it turns into a path, and then it disappears completely. In fact, the lower right would be off to the south side of this image, and you can see Grand Avenue is gone. There actually used to be a lover's lane, a pathway with trees on either side. That's gone, the road's gone. This is going back now. We've measured this pretty precisely at about 1 foot per year on average. A little further to the east, just before New Brighton are some other apartments. Those are literally right on the edge. So these are the issues that we're going to see being impacted. Local residents, invested in many cases their life savings in their home, either on the beach or on the bluffs, and those are all going to be subject to greater risks in the future as sea level continues to rise. So those are things we need to think about. West Cliff Drive's another area, but how do we deal with this? What can we expect? Are both really important questions to answer. I'll stop there, Manu.
Okay, great. Made good time. And I'm sure everyone's got lots of questions for Gary. We'll just save them till the end, till everyone's had a chance to present, and then we'll open up to questions afterwards. So let's move along to Raphe.
All right, thank you, Manu. And so I'm going to keep my science slide to one slide, but it has a lot on it, as you can see. And these are some of the things that we're interested in. And so like Gary, we're working at the land-sea interface, but focusing on the biology rather than on sea level rise and the geology, and on shorter timescales. And so we're really interested in what's happened in the last 20 years, what's going to happen in the next 80 years going forward into the future. And so a big part of what we do is just keep an eye on our backyard. We run several coastal monitoring programs. We go down to the Santa Cruz Wharf once a week, and we're measuring things like nutrients, which is related to runoff from both farms and also industry, but also people's septic systems. That feeds organisms like bacteria. And so as probably almost, I'm sure all of you know, our beaches are oftentimes on the top 10 worst beaches. And there's some good reasons for that, but we keep track of that. And then a big part of what we're doing is looking at harmful algal blooms and blooms of phytoplankton in general, and how that's related to things like a warming ocean and changing pH. In the bottom left corner, that sort of red and blue time series, that's just showing anomalies from the long-term temperature at the Santa Cruz Wharf. And really what your eye is probably drawn to is the right side, where there's those huge red peaks. And that was the warm blob that we all experienced starting in 2014 and 15. And that warm blob, Nate might talk about it, but the warm blob was a warming over much of the Pacific Northwest. But when you talk about it and you look at the scientific reports, we're talking about a degree to a degree and a half Celsius, which doesn't seem like much. It's actually amplified at the coast. And so at the coast, at the Santa Cruz Wharf, it was much, much warmer, many degrees warmer than it typically is. And of course, that impacts the biology. It speeds up bacterial growth. It selects for certain phytoplankton that we may not like so much. It's great if you like swimming. It was nice sort of tropical waters around here for a while. But a question that often comes up is, is that going to be the new normal? And that warm blob, one of the things that it did is it led to that huge domoic acid outbreak along the West Coast that shut down the Dungeness crab fishery. And so we've worked a lot on that. That sort of infographic in the second panel under partnerships is just showing the extent of that bloom and all the different marine organisms and commercial fisheries that it impacted. And so it cost a tremendous amount in terms of dollar value, but also a tremendous amount in terms of ecosystem impact. And we're still figuring out, what are the long-term implications of that, and how are we going to deal with that in the future? And so one of our big questions is, was that a one-off event, or is that something that we're going to continue to see? And I didn't put the graphic in there, but we've actually been looking at that and looking how that particular phytoplankton responds to temperature. The good news is when we use the climate change models and project into the future, by the time we get to about 2080, we won't have those blooms anymore. The bad news is they're all going to be up in the Gulf of Alaska. And so those phytoplankton are basically going to follow that warm water northward. And that means that something that's to the south of us is going to come up. And so right now, we don't think a lot about some of the toxins that they have off Baja, Mexico, for example, because we just don't see them. But in 20, 30 years, we're going to start to see those organisms following that warm water northward. And Nate will probably tell you that the fish are doing exactly the same thing. And so then on the far right, one of the things, that can all be a little bit depressing. We're talking about impacts to the coastal ocean, things that might damage you or damage the environment. But there's some exciting things going on as well. And one of them is all the new technology that we have available. And so that sort of grayscale panel on the top right, those are images of individual phytoplankton. And we're actually capturing those using essentially an underwater microscope. It's something called an imaging flow cytobot. And so it's a robot that's sitting at the Santa Cruz wharf, and it pulls water in every 20 minutes and it counts every single phytoplankton cell that's in there. And then what we can do, which I think is pretty amazing, people are taking this more and more for granted, but we use artificial intelligence and machine learning, and not only does it count them, but it tells us what phytoplankton it is. And so then we can start keeping track, oh, are there unusual red tides this year or not? And we can say, well, quantitatively, yes or no, these are what's going on in the environment. And then the bottom right one, this is showing what we can do with some of the new satellite images. And so that's just an explosion of our capabilities. This is from a satellite called Landsat 8, which gives us 30-meter resolution. There's another satellite from the European Space Agency that has 10-meter resolution, so 30 feet. It's literally high enough resolution that we can zoom in and see what color trucks are driving down the highway, for example. You can see your backyard if your backyard's big enough. And all of this data is free. These satellites come over about every 2 weeks, and you can download it and take a look at it. This particular image, what we were looking at, are some of those big red tides that we've been experiencing. And we can actually identify exactly where the red tide is and where it's likely to be impacting the beaches. And so we've been taking all of that information together and trying to get a handle on, is this year unusual, but also, is it going to look like this in the future? Is it responding to temperature? Is it responding to nutrients? And so one of the things that we discovered early on is there is definitely a nutrient connection. And so there's algae in freshwater as well that produce toxins. And we discovered probably about 8 years ago now that those toxins are coming down our rivers, getting into the coastal ocean, and then accumulating and killing things like the California otter. And that's directly related to humans because it's being stimulated by nutrient pollution. And so one of the things that we've been really working closely with the regulatory agencies on is providing the science that says there is this link, and then the policymakers can go say, okay, well, what are we going to do about it? Can we reduce the amount of nutrients that come into the ocean? And so if you can flip to the other slide, Manu. This is just highlighting how some of this science actually gets implemented. And so some of the documents that we've been involved with, I work a lot on harmful algal blooms. And so several of them are harmful algal blooms in California, harmful algal blooms internationally. But we've also been, again, exploring these connections to the California coast and to climate change. And so that bottom right one is the California Coast Ocean Summary Report that came out recently. And both Nate and Gary were on this as well. And then one I didn't put on there is all of this work that we're doing locally informs all the way up to the international level. And so over the last couple of years, I participated in the special oceans report for the IPCC, talking about, again, what's going to happen over the next 50 to 100 years. And so what I want to really emphasize is, these are local problems that we're dealing with, but they're influenced by global issues, by things like temperature rising everywhere. And we have a connection to those global issues. What we see locally can inform policy, not only locally, but all the way up to the international level. And so it's important to keep that in mind, that when you're wondering, what can I do about it? Everything that ends up in those national and international reports starts as some sort of local science that people were interested in, that was supported by the community, that scientists were interested in. And so I'll stop there. And when we get to the Q&A, I'd be happy to answer any questions about this material.
Great. Thank you, Raphe. That's really cool. The phytoplankton counter and cataloger is amazing.
It is pretty amazing.
Yeah. Nate, why don't you tell us a little about your research?
Sure. Yeah, so the group that I work with here in Santa Cruz is focused on California salmon and their habitats, trying to inform how the endangered species that exist in the state can be recovered and protected, and also how the fishery that's still ongoing and really popular and economically important for Chinook salmon can be maintained and enhanced going forward. So we have a lot of freshwater specialists because there are lots of freshwater habitat issues around California salmon, but we're also really interested in the ocean. And the ocean turns out to be a place that is typically very high risk and high reward for salmon. It's a place where they grow very fast if they survive. There are lots of hungry mouths out there, a lot of competitors and predators. And when our salmon go to sea, they're about the size of an anchovy, which you might know is something that almost everything out there likes to eat, from seabirds to harbor seals and sea lions, other fish, all the way up to humpback whales. And we know that cold years have typically been better for the food web that our salmon exist in, and the warm years have typically been worse, and that's true all the way up the west coast to central British Columbia, and even in recent years all the way into southeast Alaska. And something that has really struck me over my career in looking at climate and natural resources is that when we talk about the future and climate change that's caused by this buildup of greenhouse gases, we're usually looking at the output of models that's been averaged in ways that makes it look like a smooth ride into a warmer future. The world that we live in is so much different than that. It is a very rocky road that has lots of peaks and valleys, and some of these end up being extreme events. This summer, hottest August on record. And it's come with some of these extreme heat waves that have catalyzed extraordinary wildfires that just have never been experienced, not just in California, but Oregon and Washington as well, just in the last few weeks. During this marine heat wave period from 2014 to 2016 and the entire Northeast Pacific, so this includes the Gulf of Alaska, all the way down the west coast off of Mexico, out towards Hawaii, the ocean was warmer than any time in our historical records. In 2015, that calendar year had the warmest year of any in the last century where we've got good records. So we know that the ocean normally has these periods that are warm or cool that are related to things like the tropical El Nino, La Nina cycle that is natural. It's always existed for many tens of thousands of years, and it's always had an appreciable impact on both our ocean temperatures and currents and marine life, and also the winter weather that we experience here on the coast. But it's this combination of some of those natural variations that happen from week to week, season to season, year to year, and the longer term warming that is bringing us into what I consider to be an era of surprise, at least in terms of what happens with our ocean ecosystems and on land as well. But for the ocean, I've been keeping a list that is growing every year, it seems, about big surprises that have come to the Pacific coast. And Raphe talked about one being this extraordinary harmful algal bloom in the summer of 2015. It had widespread impacts on all kinds of marine life and fisheries, and it lasted an extraordinarily long period of time. And from Southeast Alaska all the way to Santa Barbara, it had impacts. So this is really unprecedented for its size and its duration and its reach. During the same marine heat wave, we saw a collapse of the kelp forests on California's north coast. And this was kind of a complicated story because it really began with the die-off in an important predator, the sea star disaster, the starfish that is a key stone predator in our coastal intertidal areas. And they started dying and wasting away over very broad areas, again, from British Columbia all the way into California. During that heat wave, the disease spread more rapidly, became a lot more problematic for them, and they died at really high rates, and it basically released purple urchins from that key predator, and purple urchin populations exploded. And these guys are super grazers and very abundant and voracious feeders, and they mowed down the kelp forest on the north coast. This is the food supply for our red abalone. So the really popular sport fishery for red abalone that existed on the north coast has been closed for a couple of years because they have lost their habitat and their numbers have plummeted. So this is a big surprise. Nobody saw this coming. Other things that have happened, there's been sort of an explosion of what's called pyrosomes, these gelatinous creatures that feed on plankton out in the ocean. And they became very abundant during this marine heat wave and have persisted along much of the West Coast from Washington all the way down to here in California. During that period that shut down the crab fishery because of the harmful algal bloom, we also saw a big spike in whale entanglements off the West Coast, especially in California, and really especially in the Monterey Bay, Gulf of the Farallones region, where humpback whales were getting tangled up in Dungeness crab fishing gear from the really lucrative and popular commercial crab fishery that typically starts in November, then goes all the way into the next spring or summer. What happened, we believe, is during this warm period, the food supply for humpback whales shifted. And during cold productive years, they're frequently targeting krill out along the edges of the shelf, continental shelf, and at the heads of our submarine canyons. During this marine heat wave, krill were scarce. But another big surprise was this resurgence of California anchovies in our region. They were really scarce before 2014, but starting in about 2014, 2015, their abundance became really high, and their concentrations in shallow nearshore areas became extraordinary. And you probably saw them many times in the last few years. If you've been out to the beach, seen humpback whales lunge feeding on anchovies. There were times near the head of the Monterey Canyon at Moss Landing where you could stand on the beach and watch dozens of humpbacks lunge feeding all day long. And there's some incredible videos of kayakers and paddleboarders getting really close to these giant animals who are just having a feeding frenzy. And of course, lots of other top predators are mixed in. Well, the whales were just unusually very abundant in these crab fishing areas. And in the spring of 2016, when the domoic acid levels finally dropped and allowed for safe harvest and consumption of our Dungeness crab, a lot of crab gear got set right in areas where these whales had been feeding. So that led to just a surprising overlap in both space and time of this crab gear and feeding whales. And my work has really been kicked around, I think, in recent years because of these big surprises. This year, a project that I just started is related to a vitamin B deficiency that has been identified in California's Chinook salmon. And it was first seen this winter in the hatcheries when juveniles from last year's spawning fish were hatching, and the juveniles were swimming in circles or not feeding and dying at unusually high rates. And some scientists who work there in the hatchery system recognized that as something that had been seen in other parts of the world. And we believe it's related to this shift towards a really anchovy-dominated diet, and that anchovies produce an enzyme that destroys vitamin B1 in animals that just eat it and nothing else. So it'd be like just a whole diet concentrated on Big Macs that is plenty of calories, but it's not the only thing you should be eating. You need more balanced diet to meet all your nutritional needs. And this one is kind of an ongoing study that we're just in the midst of right now, and I expect you'll be reading about it sometime soon. But the more general story to me is we are in the midst of an era of big surprises because the ocean is changing so rapidly in terms of its temperature, its carbon content, and the pH. If you heard about ocean acidification, it's starting to impact marine life in ways that we don't have an experience with. And these different dimensions of the ocean are changing rapidly, and sometimes with extreme events like these marine heat waves, it becomes much, much warmer and much more different than the sort of average conditions of the last 30, 40, 50 years. And the marine life is responding very quickly. Sometimes we can predict what we might expect, like the northward shift, warm water species. We see things that are typically off Baja California or Southern California show up here. But then sometimes we see things that no one has any experience with, and it's a really big surprise. And in terms of dealing with this era of rapid change, you know, I think that there are short-term actions that are obviously within reach and really important to consider. Raphe talked about some of these things like nutrient pollution. You know, we can actually control that. It might not be easy, but it's something that it's really under our influence, and it's our infrastructure and just the way that we live here on land. There are restoration activities in our estuaries and coastal areas that can make space for climate change. And that is a theme that I've really thought a lot about for salmon, is that a lot of their freshwater habitat has been damaged and degraded in ways that any further insult to them can kill them off and make them locally extinct. So we need to make space for climate change because it's coming, and we can't stop this quickly. But that's the longer term challenge, is trying to put the brakes on climate change and ocean acidification. We've got a really incredible global carbon problem that has to be dealt with, and we are not dealing with it at all. And this really requires concerted action to get carbon out of the atmosphere, because when it goes into the atmosphere, about a quarter of it ends up in the ocean. So that's the pathway to starting to reduce this global problem. And it's going to be a long-term effort to get there, but it's necessary if we're going to reduce a bunch of problems that we're already in the midst of. We're just kind of at the front edge of it, though, is what I would say. If you look at projections for things like acidification or global warming, you know, we're just starting to experience these things. And if we don't get off this trajectory, it's going to get a lot worse.
Thank you, Nate. That's very sobering. I think it's important to understand. I mean, as you said, that you know, we're dealing with just a lot of variability right now, and we need to look at both short-term adaptive measures that we can take, but also to the long game. So we've got a lot of questions. I mean, that was a lot of research to condense into about 30 minutes. And you know, I've got a bunch of burning questions for you on, you know, what we can do about it and how we can implement, you know, how we can turn these into policy solutions and change course here. But also, we had a lot of questions come in from the audience just now, really about some of this primary research. So I'm going to field a few of those first, and then we can shift a little bit to what we can do about it. Let's see. From the first question actually is what you were just finishing on there, Nate, about taking carbon out of the atmosphere. It's from Michael Lewis. He says, when did this cycle of sea level rise begin? And if CO2 emissions were stopped, would sea level rise stop? Or maybe, you know, Nate or Gary, you can answer that.
I'll pass that to Gary because he's authored a really nice report on those issues that he can summarize better than I can.
Okay. All these questions, would involve a book in themselves, but we're going to try to keep this brief. So basically, we have had climate change on the planet ever since we've had an Earth and a sun, because their relationships, distance change, the amount of heat we get changes over cycles of tens of thousands of years. And we know those pretty well from the historic geologic record. What has changed in that very first graph I showed is that things that have been stable for hundreds of thousands of years are now changing really quickly. So climate change is not new. It happened way before humans were on the planet. It goes back 4.5 billion years. The important point is it's changing much more rapidly now than it ever has, and it's because we have had a major influence on the atmosphere by putting in greenhouse gases. And despite how many Priuses we drive or whatever else we drive, the global carbon dioxide emission rate is still going up every year at about 2.7%, and the US and China make up about half of that. So we have a lot of work to do, but I think without just giving up hope, we can't change it tomorrow. If we all went to solar and wind, renewables tomorrow, there's so much greenhouse gas baked into the atmosphere that we're going to keep seeing the impacts of this, whether it's the ocean or the land or whatever, for decades. But the sooner we start to get it under control, the better off we're going to be in the long run.
So, I mean, if we stopped adding carbon to the atmosphere today, we would still be dealing with the repercussions for years to come of what we've already done.
Exactly.
Yeah.
And there's this idea, well, can't we just suck it out of the atmosphere? Well, I guess it's like trying to suck the pH out of the ocean. It's 330 million cubic miles of water. And the atmosphere is even bigger. There's gonna be a lot of people inventing a lot of things to suck CO2 out of the atmosphere. I think we could just put it all in carbonated beverages and we'd be great. But it's a big atmosphere. And I think relying on some technology to get it out of the atmosphere, or geoengineering, all the studies been done so far say, we're not ready to try that yet. Shooting mirrors up there, gases, we got to deal with our sort of backyard here where we know we can have an effect. It's going to take time, but it mainly is a political issue when we start making decisions that are going to start to reduce that dependence on fossil fuels.
Right. So what I hear you saying, Gary, is that you think just ceasing fossil fuel use would be the best first step, because trying to suck carbon out of the atmosphere would be really just too unpredictable, or require.
Well, I'd say sucking it out of the atmosphere is, I'm going to say it's impossible. We don't have the scale. We can stick a vacuum up there or something. It sounds easy. I just don't think it's possible on any scale. That and just using less energy, which is a local thing, whether it's fewer cars or, discouraging cars versus all the other ways of transportation, all the requirements now for our electrical use and requiring solar panels, all that's going to help.
Mm-hmm. Got it.
That's your baby.
Yeah, absolutely. Yeah, changing land use patterns so that we're using less energy in transportation.
Yeah.
Most people don't realize, but 60% of our emissions here in Santa Cruz County come from transportation. And so just creating more walkable communities will go a long way towards getting our local emissions under control.
Yeah, we could put them on that rail.
Right. That definitely runs through the middle of things, and will have a big impact on the shape of our community in the future. I have a question for Dr. Kudela. The recent huge, from Steve Mandel, the recent huge wildfires, a result of climate change, are dumping ash into the ocean. This ash is a food for phytoplankton, especially this time of year. Is there any chance of a harmful algal bloom from all of the ash?
It's a great question. We're tracking that right now. And so there's a project that's been spun up with various universities and NOAA to see what happens, particularly when it starts to rain again and the ash that was deposited on land and the ash in the forests ends up in the ocean as well. But the short answer is yes. We saw this in the Thomas fire down in Santa Barbara a few years ago. We happened to have that automated microscope out on a student research cruise, and the ash plumes were coming over the Santa Barbara Channel. And if you're familiar with Santa Barbara, the water's pretty blue down there. Everywhere that the ash was raining down, we saw a pretty significant increase in phytoplankton, and specifically in 3 or 4 groups that are potentially harmful. And so we did see a really nice direct connection where under the ash plume, there was this response. Outside the ash plume, there was not a response. And so we're fully expecting, if those organisms are around and everything else is correct for them, that ash from these fires here in the Santa Cruz area, it could quite possibly stimulate a bloom that, you know, is not super good for us. And so we're actively keeping an eye on that, and you know, we're setting up this network to look at it, how it changes across the whole state, because of course the whole state is experiencing wildfires.
Yeah, right. So could definitely be seeing some harmful algal blooms soon. Here's an easy one. Then it's one that I think we all hear a lot, which is Fukushima radiation still polluting the California coast, and will it continue to? Anyone?
I know Nate wants to answer that.
Are you seeing it? Are you seeing it show up in salmon, Nate?
No, we haven't had any effort at all to focus on that as a problem. That I think other labs that have been looking for evidence of a problem associated with Fukushima radiation off our coast have found nothing to be concerned with. That we did talk a little bit about this question before the panels went live, and something that strikes me is that there are other ocean pollutants to be more concerned about. And for instance, we know about mercury contamination in top predators in the ocean. So in large, long-lived, high on the food chain species like bluefin tuna or swordfish, they're known to bioaccumulate mercury that's coming from atmospheric deposition mostly, that basically rains out of the atmosphere, gets into the marine food web, and then gets bioaccumulated by these top predators. So that's really more of a pressing concern than Fukushima radiation in our marine life.
Got it. Okay, a question from Jerry Jensen to Nate and Gary. In light of all these big surprises, what is a guess as to when Santa Cruz oceanfront real estate will be impacted by rising sea levels? E.g. 26th Avenue, Pleasure Point, Westcliff Drive. We're talking about 10 years, 20, 50. What are our other high-risk areas besides Capitola?
I would say, as I spoke about earlier, there's 2 areas of concern. There's the low-lying areas, downtown Capitola, the beachfront in Rio Del Mar, Aptos, and then there's the cliff areas, Depot Hill, Opal Cliffs, Westcliff. Westcliff just finished sort of a hazard and management program that I think is next step is going to be, what are we going to do along at Pleasure Point? We've kind of decided to stabilize that shoreline because of the sewer and the water line. So it's already a problem. If you go on the bike path on Westcliff now, you can see some barricades because parts of the path have fallen into the water. And I guess it depends on property values is another issue. It's definitely happening along the East Coast. The South Atlantic coast from hurricanes, some insurance companies are no longer insuring homes, which means banks are no longer going to give you a mortgage. That hasn't happened in California yet. I think the most expensive property in California is right on the coast, but will it take another couple of El Nino years? Or because I think Nate talked about this, there's this long-term sea level rise of, 3.5 millimeters per year, but then there's these spikes on top of it. It's an El Nino year. It's a very high tide with storm waves. So those are going to be cumulative over time. And it's when we get sort of 2 things happening at the same time, like we had in 83 and 97, 98. So we're already experiencing the problem. How soon it hits a crisis point is going to depend on where we are. I do a fair amount of coastal consulting for people that are worried about that, and it's a widespread issue.
Yeah, and I think that a lot of these types of climate-related problems, whether it's a hurricane that hits the Gulf Coast, or a big winter storm that comes in and does a lot of damage to our coast, we can't really predict the year or maybe even the decade when it's going to happen, because it's this mix of more predictable slow changes that are due to this more gradual climate response to building up greenhouse gases and warming, with the less predictable El Nino that we know can keep the sea level about a foot higher than what it says in your tide book for a whole winter. And then a storm on top of a high tide that is at that really high amplitude part of the tidal cycle. So there are a lot of moving parts, and then sometimes they all come together. And that's when you have a lot of problems happen. And you see that with storm surges on hurricanes in the East Coast as well, that if that comes during a high tide period, of course, that can really impact how high the ultimate water level goes and how far it moves inland and what it damages.
Right. Yeah. Again, a lot of variability in how fast this happens, and even from one year to the next. So we've got just 13 minutes left. So I want to shift a little bit to positive things that we can do. We've got, the question is, clearly we need some drastic changes, and the costs of a runaway climate crisis are, astronomical, whether it's all the oceanfront real estate or, collapsing fisheries, or, other changes that we can't even imagine. So what do you feel is the biggest single thing we can do as humanity to slow a rapidly warming Earth, or to begin to, I suppose, just reduce our carbon emissions?
I'll be really bold and say there's one thing everybody can do: vote.
Yeah.
Certainly.
We have to have the conviction. First, denial is over. It should be over. Whether it's the increased number of hurricanes and their magnitude or intensity, whether it's the increased fires, and you don't have to go too far to see that from last year and this year. The 5 of the biggest fires in California's history have all occurred this year. Those kinds of numbers, you can't deny that. We can't deny sea levels rise at an accelerated rate. We can't deny the things Nate and Raphe have been talking about. So ultimately, it gets down to the atmosphere that's affecting the climate, which is affecting all these other things. And I think a couple of things I would like to dispel. We talk about a new normal. That sounds like it's a plateau and now we're all safe because we can handle this. All the curves are going to continue to go up, and probably at an increasing rate, whether it's, we don't know, harmful algal blooms, or, Chinook salmon, or kelp forests, or sea level rise. And I think for some people say, well, I can handle it's a few degrees warmer. As we've heard tonight, there's a whole lot more things connected to the climate that we now understand better. And it's going to affect our lives, our children's lives, our grandchildren's lives. So the sooner we start by going, simplest way is using less energy, going to renewable energy. And, many, many more jobs today in wind and solar than in, say, coal. Coal's history. And the sooner we make that happen, the better. Oil and gas, a little more complicated, and we can't go 100% renewables tomorrow, but boy, we can go a lot faster than we're going.
Right. And so let's say I was running for president right now, Gary. And there was one
I would
policy,
back you.
No, tough job, believe me, supervisor's enough. But if there was one policy that I could implement, I think, and correct me here, but if I'm wrong, but I think a carbon tax that was, maybe ultimately returned to people as a dividend, but at least shifted people's choices from day to day, would probably be the single best thing that we could do at the federal level. Is that right?
That's certainly one important step, however we bring that about. But I think, again, getting past denial.
Hmm.
We had this with the president's, trip to the fires. Wait around, it'll get cooler.
That's great.
I would just comment, Gary, in addition to that, 100% that we have to give up on this idea that it's not happening or it's not going to impact us. But, when Manu becomes president, the easiest thing to do is to sign back up for the Paris Climate Accord, which we were part of and we walked away from. That was an international agreement to head off climate change. And that's where we need people to step up and say, no, we should be part of that.
I think what that brings up, Raphe, is the impact of the United States. What we do propagates around the world. California has a much, much larger impact than almost any other state. People look to California. What are our emission standards? How are we dealing with whatever it is? And in fact, I think, in California, we don't look at Yolo County or Alpine County. We look at Santa Cruz or Santa Barbara or Santa Clara. So we have a much bigger impact on what decisions we make here, what policies we set in place than we might think. So everything we do here is important on a larger scale.
I completely agree. That's of course why I'm running for supervisor. Is I think that the changes we make here, really Santa Cruz, we punch above our weight class as far as influence on the rest of the state and the rest of the country even. And if we, I think the biggest thing we can do here is change our land use patterns, more infill development that will, by law be covered in solar panels. And so that'll increase renewable energy production. It'll shorten the distance that people have to go, which will reduce emissions related to transportation. So because everyone will be able to walk to a corner store. So I think those are some of the biggest overarching changes that we can make locally. Raphe, we talked a little bit about this before, but it seems like allowing more, composting toilets or gray water systems would also go pretty far in terms of reducing runoff that causes harmful algal blooms.
Absolutely. One of the things that surprised us is when we were looking at the connection to nutrient pollution, everybody immediately jumps to, oh, it must be the ag fields. And there certainly are nutrients coming from agriculture, but one of the biggest culprits was leaky septic tanks. And so not even going to composting, it would be a huge improvement, but just making sure that if you're on septic, that it's being maintained, would have an immediate impact on our coastal ocean. And then on top of that, recycling gray water, which also helps with our drought issues. More composting. Composting actually eventually results in less carbon dioxide in the atmosphere as well because of the way the biology works. And so there's lots of these things that, there were good reasons why it was made more difficult because cities and counties wanted to keep track of exactly what was going on, but we know what we're doing now and it could be implemented safely and would have an immediate impact.
Right, yeah, there's things that we can do immediately. And Nate, to your point about making sure there's water left over for the salmon, are there any particular, we've obviously had a really big debate in our community about water alternatives and conservation. It started around the desal plant. Now we're talking about in terms of recycled water plant. What solutions do you like that would make sure that we retain enough flow in the river for salmon and continue to support these ecosystems?
Yeah, so some things that have been pretty well documented is that during that really terrible drought that we just experienced from 2012 through about 2016, depending on where you were in the state, the runoff and water supplies that people depend on were much reduced. And of course, what was left over going down our streams for fish and wildlife was also greatly reduced. And in some places, conditions were really intolerable for some of our salmon and steelhead populations in places like the Central Coast or in the Central Valley. So coming up with ways that we make room for environmental flows during these periods of scarcity. California's climate has always had drought and floods. That's just part of this kind of natural climate state that we live in, and it's really volatile. When we build systems that have basically a floor that doesn't have any flexibility and always demands some amount of water from something that it's not there, and then some of the biggest losers have been our fish populations, our cold water fish, so salmon and trout, steelhead in California. So it's really important, if we want to keep them around, to make space for them during droughts. And that will benefit from coming up with more flexibility in how we use water on the landscape, and whether it's in recycling programs or cisterns and sharing agreements among different water districts, or coming up with something like environmental water rights for ecosystems, so that that water gets used when those fish need it most, would be pretty helpful and really doable things depending on where you are, which watershed and what the situation is there.
That's interesting. Both cisterns, we've seen some really cool cisterns in Australia, since they're another region that deals with severe water shortages like ours. And also this idea of environmental water rights, that's compelling as well. Definitely an idea to work on. One thing that occurred to me as well when we were talking is that you guys are all doing incredible primary research, and as you said, all of this stuff that impacts the global discussion starts right here with research locally. And it strikes me that a lot of regions, whether it's Pittsburgh, for example, with robotics, has really done a great job of combining the university system and primary research with government actors and also the private sector to create a hub of innovation around, in their case, robotics. But in our case, we could really have an opportunity to do something similar around marine research and solutions. And Gary, I can't remember exactly how many marine institutions we have here, but it's like 27, 32, somewhere in there?
20s, yeah, and maybe, God, the annual budget now is about $350 million in research and education, and I think maybe 2,500 people involved. So we are this incredible global center for marine research and education, and there's a lot of collaboration and interaction. So we have, and doing some amazing work, whether it's National Marine Fisheries or the university or Moss Landing or Monterey Bay Aquarium Research Institute. These are facilities that are known worldwide. So we're in a great place to call on those scientists to help out. And I think one of the most important things anybody would hear is, can you help me? Can you give me an answer for this? And I think some of us are maybe more involved than others because of what we do. And this is maybe panel's a good example, but I think those partnerships are incredibly important.
Mm-hmm. Yeah, it's definitely a place I would start as well, is make sure we have the organizational structure to make those partnerships easier. Well, great, we're out of time. I know there's a lot more questions from the audience that we didn't get to, but unfortunately, it's hard to cram this much knowledge into an hour. But I'm happy to share some of your questions with our panelists later, and if they have an opportunity to respond to them, maybe we can post those on the website or on social media. And finally, I just want to thank all three of you panelists for being here tonight. Gary, Raphe, Nate, keep doing the incredible work that you're doing, and we need it not only locally, of course, but globally. And we really appreciate you coming here tonight to share your research with us.
Thanks, Manu.
Yes,
and
thanks,
Raphe
Manu.
and Nate.
Yeah. And thank you all the members of the audience who came out here tonight. You heard it from Gary. Best thing you can do is vote, and you have an opportunity to do that very soon. You'll be getting your ballots in the mail at the beginning of October.
Great.
So thank you again, and good night.